Hello students, today we are going to discuss about the thermodynamics enthalpies. We will discuss all the enthalpies. What do you mean by enthalpies? Enthalpy means it represents the net heat content of the system. Okay, so now there is so many types of enthalpies. We will cover up all. So first one is the enthalpy of reaction or heat of reaction. It is a term used for the heat changes accompanying with any reaction. Means heat changes with any reaction according to the reactions. Okay, so now we will discuss about the enthalpies. First, enthalpy of combustion. Enthalpy of combustion said that it defined as the heat change when 1 mole of substance is completely burned or oxidized in oxygen. Okay, it is denoted by the delta C H. Okay, C it is denoted for the combustion and H is enthalpy. Okay, so example, CH4 methane gas plus O2, 2O2, 2 mole, here is 1 mole, here is 2 mole, is equal to carbon dioxide plus water. 1 mole methane produces 890.4 kg mole after burned. Okay, so standard combustion of enthalpy is 298 Kelvin or 1 bar pressure. Okay, so here is another equation, C6H12O6. This is glucose equation and this is oxygen equation, where then it release carbon dioxide and water. Okay, so here you can see that it is the stable equation. Now we will discuss about the 1 mole of glucose. 1 mole of glucose contain 180 gram. Like how atomic mass of the carbon is 12 and it has 6 atom of carbon. So 6 into 12, you will get the answer. Then you will add up the 1 1 into 12, then add up 6 into 16, because oxygen has the 16 atomic mass. Okay, so 1 mole of glucose produces 180 gram. When you add up all, you will get the 180, and produce heat is 2840 kilojoule. So calorific value of glucose is 2840 upon 180 is equal to 15.78 kilojoule per gram. Okay, now we will discuss about the second enthalpy, which is known as the enthalpy of formation. It is known for the defined as the heat changes. It means heat evolved or absorbed when 1 mole of substance is formed from its element under the given condition of temperature and pressure. Okay, it is denoted by the delta F H note. F it is denote for the formation and H is known as enthalpy, as you know that. So here is the equation, delta H reaction is equal to sigma delta HF, which is product minus reactants. So we will take the example of that. CH4 plus O2 is equal to carbon dioxide produces plus water. So here is the reactant and here is the product. The enthalpy changes may be calculated as follows. Delta H, change in enthalpy. So we will take first product as per the equation. So here is the product. We already took the product minus reactant. Here is the reactant. So CH4 methane is the reactant and O2. So they gave us this equation. You don't have to worry about these numbers, because they will give you in questions about these numbers. And here is the question. Here is 2 mole, so we will also into it with 2 mole. Sorry, this one, 2 mole into heat produces by the H2O minus this, then you will get the minus 890.3 kilojoule per gram mole. Okay, hopefully you understand the equation, hopefully you understand these two enthalpies. So let's discuss about the third enthalpy, enthalpy of neutralization. It is made for strong acid plus strong base made the salt. So it has the constant value delta. Neutralized enthalpy is equal to minus 13.7 kg per mole. So strong base plus weak acid, weak base plus strong acid, weak base plus weak acid, they are all are small, as compared to this equation. Okay, so it defined as the heat released when 1 gram of equivalent of acid neutralized by the 1 gram equivalent of base. Okay, so this will not come in exam as per these syllabus guidelines. So let's take the another enthalpy, enthalpy 4, enthalpy of dissociation, bond energy and bond enthalpy it is also known as. Okay, so it is defined as the heat required to break the bond of 1 mole of molecules in its gas phase to its gaseous atom, like hydrogen molecule to 2H gaseous, delta bond enthalpy H bond H, C bond C in gaseous is given the 2C gram bond enthalpy. Okay, so take the another enthalpy, enthalpy of phase. It is the heat required to change the phase of 1 mole of molecule, example, H2O liquid to H2O gaseous, it is known as the delta vapor enthalpy. H2O solid to H2O liquid, it is known as the delta fusion enthalpy. And H2O solid to H2O gaseous, it is known as the sublimation. You already studied this enthalpy in the standard 9th standard or 10th standard in your science book. So let's talk about the another enthalpy, enthalpy of atomization. So heat required to convert 1 mole of any molecules into its gaseous atom. Delta A enthalpy or delta HA, it is denoted by this. So example, H bond H in gaseous state gives the 2H gaseous, delta A enthalpy. It is equivalent to delta bond enthalpy. So carbon bond carbon in solid state gives the 2C in gaseous state. So it is delta A enthalpy, atomization enthalpy is equal to delta sublimation enthalpy. Okay, they both are interconnected, enthalpy of phase and enthalpy of atomization. Basically all the enthalpies are interconnected. Hopefully you will get the answer. So lattice enthalpy, lattice delta lat of enthalpy, heat required to convert 1 mole of molecule into its gaseous ion. Okay, like a heat required to convert 1 mole of molecule to its gaseous ion. We will convert any bond to its gaseous level plus in ions level. Okay, like take the example of NaCl. NaCl gives the Na cation, here is the positive charge gas in gaseous state, plus chlorine negative charge in gaseous state. So it gives the general formula at atomization energy plus ionization energy gives the lattice energy. Okay, so another one is the enthalpy of hydration. It is the most easy enthalpy, so it denoted by the delta Hyd enthalpy. So it is the energy released to convert 1 mole of gaseous ion into its aqueous ion. Aqueous, here is come to aqueous, so it is for the water. So NaCl cation in gaseous level plus Cl negative anion in gaseous level gives, when we add up the water, gives the Na positive in aqueous level plus Cl negative in aqueous level. Okay, so we all let's discuss about the another enthalpy, enthalpy of solution. Heat exchange to convert 1 mole of molecule into its aqueous ion. Like example, NaCl solid, when we add up the lattice energy, it's breaking its bond, so we required some energy, and when we required to break the energy, we have the positive charge enthalpy. So Na positive cation in gaseous level plus Cl negative in gaseous level. So when we do the process, we get the Na positive in aqueous level plus Cl negative in aqueous level. So we get the delta solution. Okay, here is the note. First one says that to bond break, when we break the bond, we required some energy, so our enthalpy will be positive. Okay, and second note says that to bond formation, in the formation of any kind of bond, we need to release the energy, so our enthalpy will be negative. Okay,